Hi everyone, and welcome to the first in our series on Object-Orientated Programming in JavaScript. Object-Orientated Programming is when programs are written in terms of objects and classes, and this differs from functional or procedural programming, where programs are written as a collection of functions, sometimes termed modules. This series is a companion series to our Object-Orientated Programming series, where we cover all of the basic concepts in object-oriented programming. This series will make use of the same concepts, but show how we can go about implementing these concepts in JavaScript, and more specifically in the web browser. Object-oriented programming is when programs are written as a collection of objects which interact with one another. Objects are unordered collections of variables and/or functions. Variables within an object are called an object's properties, whilst functions within an object are called an object's methods. And this means that properties are things an object has, for example name, age, height and weight, whilst methods are things an object can do, for example walk, run, swim, fly, and so on. Variables in JavaScript are loosely typed, and this means that a variable which contains a string can be changed to contain a number or a boolean, meaning true or false value, at any time. Changing the data type of a variable does not result in any errors because in JavaScript variables are loosely typed. As a result, an object's property may be overwritten at any time to become a method, or one of its methods could be overwritten to become a property. As a consequence of this, in JavaScript an object's members are often termed properties, regardless of whether they are properties or methods. In JavaScript there are many ways of creating objects. The easiest and most commonly used is the object literal. Here we have an object called person with the properties first name, last name, and getFullName. Notice that we start and end our object with curly braces and that each property is separated by a comma. There is no comma following the last property which we declare, in this example the getFullName property. Also notice that the names of the properties are separated from their values by a colon, not an equals sign as you might expect. Finally, it is important to note that you can use as a property name anything you could use as a variable name. Notice as well that it is not possible to leave properties empty. This example here would result in a syntax error, unexpected comma, because the interpreter will expect there to be some value there. Let's take a closer look at the getFullName property in our person object. It creates a variable res and sets it equal to this.firstName concatenated with a space and then concatenated with this.lastName. It then returns the res variable. This means that when the getFullName method is invoked, it will return the string Sean Jackson with a space between Sean and Jackson. The keyword this refers to the object of which the property is a member, in this case the variable person. This method would perform exactly the same if we replace the use of the this keyword with person. The keyword this is the recommended way to reference the object from within one of its methods. Consider the following example. Because we have created a variable within the getFullName function, which is called person, when we try to access the person object, the interpreter will instead try to access the person variable we just created, and we will not get the desired result. Objects in JavaScript are mutable. This means that properties can be overwritten, new properties can be added, and properties can be removed at any time. Here are some examples of how we can access an object's properties. Notice that in the first example we say person.firstName, and in the second line we say person open square brackets, open quotes, last name, close quotes, and close square brackets. The first example is dot notation, and the second example is square bracket notation. Dot notation is more commonly used, but both are equally valid. Remember that with square bracket notation you use a string to specify the property's name, and in JavaScript we can contain a string using either single or double quotes. The next two lines do the same thing. One is done with dot notation and the other with square bracket notation. They both create a variable called fullName, and invoke the getFullName function. This means that the fullName variable will be equal to the return value of the function. The method variable in the next two examples looks very similar, but actually does something very different. Because there is no use of parenthesis, the opening and closing brackets, the function is not invoked, the commands within the function are not executed, and consequently there is no return value. The variable method instead points to the function itself, which is different from getting the result of invoking the function. We can change the value of any of the object's properties. Here I've changed the value of the last name property to Shaw. We can also add a new property to the object. Here I've added the middle name property with the value Alan. Notice that because the new property is on the left-hand side of the assignment statement, the interpreter will add this property to the object if it doesn't exist within the object already. In this next example, we set the variable age to the age property of the person object. Remember, at this point there is no age property in the person object. This will result in the age variable having a value of undefined. It is important to note that because the non-existent property is on the right-hand side of an assignment statement, that this line does not alter the object in any way. Now let's look at removing an object's properties. If setting the variable age equal to person.age results in the age variable having the value undefined, you may think that removing an object's property would be as simple as setting that property equal to undefined. Unfortunately, this is not the case. Setting the property's value to undefined means that attempts to access the property will return undefined, which is exactly what would happen if we tried to access a non-existent property. However, setting a property to undefined does not remove the property from the object. The object still has the property, it's just that the value of the property is undefined. The only way to remove a property from an object is to use the delete keyword. In this example, the object no longer has a getFullName property. Also notice that it is possible to create an object with properties that have the value of undefined, and also it's possible to set an object's property to the value undefined. In both cases, however, the object still has the properties, it's just that they have the value undefined. In practice, it often doesn't matter whether you have removed the object's property or just set it to undefined, because as I've already explained, the behavior will be similar in many cases. However, if you're adding and removing properties from an object dynamically, you will find that once you have more than about 32 properties in the object, you may suffer some performance issues. Your JavaScript may start running more slowly. In general, unless you have a specific reason not to, it is best practice to delete an object's property rather than set it to undefined. Now let's take a look at how we can easily loop through all of the properties of an object. We say for var I in person, where person is the object we want to loop through, and we want to be able to reference the property within the loop by using the I variable. Note that I contains the name of the property, not the value, and that we would place the I variable in square bracket notation to access the property's value. In this example, we output the property's value to the console. Notice that this will loop over all properties, including those whose value is undefined, but not those that have been properly removed from the object using the delete keyword. Also notice that the dot notation won't work for this example. As you can see, person.I is asking for the property called I, which is a member of the person object. This will output to the console undefined for every iteration of the loop, because the person object has no I property. It has only the properties first name, last name, and getFullName. If we think about this for a moment, we can also see that each iteration of the for loop takes place after the last. The iterations of the for loop do not occur simultaneously. Therefore, we know that the properties of the object are in some order. However, the order is not considered to be significant. What this means is that the order is not preserved. It will change seemingly at random whenever you do anything with the object. Some browsers may preserve the order better than others, but as a rule of thumb, the order of an object's properties is not reliable. Objects are unordered collections of properties and/or methods, and designing your script assuming an order to an object's properties is bad practice. Where order is significant, use arrays. Two final points before we finish this tutorial. It is possible to have objects within objects, where one object is the property of another. In this example, I have a var obj object with the properties A, B, and C. The property B is itself an object with properties X and Y. And finally, you should be aware that whilst we have made use of the object literal means of creating objects in this tutorial, it is not the only means of creating objects. Aside from functions to create objects that you can write yourself, there is the new object method and the Object.create method. The new object methods shown here are included for the sake of completeness. They are not recommended to use. The Object.create method is actually the recommended means of creating objects, but it's a little more complicated to understand how it works. Though Object.create is recommended, there's nothing wrong with the literal notation we've made use of in this tutorial. I use it all the time, as do many other JavaScript developers. We will be delving into the Object.create method in subsequent videos in this series. In all of the examples on this slide, we are creating empty or blank objects. There is also another way of looping over objects, which involves making use of the Objects.keys method, which again is a little more complicated and something we will delve into in subsequent videos. To recap today's lesson, properties and methods are commonly called properties in JavaScript. There are several ways to create objects, with the Object.create method recommended and the literal notation fairly common. We can use dot notation or square bracket notation to access an object's properties. Trying to access a property that isn't there will result in undefined. We can set a property to undefined, but we must use the delete keyword to remove a property from an object. Objects are mutable. Properties can be removed, added, or overwritten at any time. We can loop through properties in an object, but the order of properties is not significant or preserved. Where order is significant, we should use arrays. In the next video in this series, we're going to look at the concept of passing by reference and passing by value, what these terms mean, and what their significance is in JavaScript with regards to objects. We're also going to be looking at the phrase, everything is an object in JavaScript, and we're going to explain what this means and why it is a slightly misleading statement, but when properly understood is a major revelation of the inner workings of the JavaScript language. That's it for this video. I hope you enjoyed it. Please leave any questions, comments or criticism in the comments section below, and as always, please rate this video, subscribe for more, and I hope to see you there. Till next time.